Hello everybody, welcome back. This is lesson 3 in unit 12. So the past couple days we went into what organic chemistry was, properties of some of the organic compounds. Yesterday we talked a lot about naming different compounds, so alkanes, anything with single bonds, alkanes with branches, alkenes, stuff with double bonds, and alkynes, stuff with triple bonds. So today is just basically practicing naming all these types of things. There is a set of 16 questions. So what works best is if you kind of try those on your own and then check back in this video to kind of go through each of the questions in more detail. Just a heads up on dates. It looks like tonight you have counselor number 21 on hydrocarbons. That is due tonight by 11:59. Just make sure that you are following the calendar and whatever other announcements your teacher may or may not have for you. Okay, so let's get started. Number 1 says which compound is saturated. So remember, saturated things have all single bonds. So we talked about S for single, S for saturated, and anything with single bonds are considered alkanes. So anything that ends with the A-N-E ending is an alkane. So butane, this is a single bond, it's an alkane. Ethene and heptene, these are enes, these are double bonds. And Y-N-E, ine, is a triple bond. So double triple bonds are unsaturated, meaning more H's can attach. There is the capacity to have more H's attached, where a single bond is saturated because there is no more room possible for other things to join. So butane is the answer. Again, single bonds, A-N-E, simple explanation. Number 2, this says what is the chemical name of this compound? So you can do this a few different ways. The easiest way is to just write the formula for this. So there are 4 carbons and 10 H's. So this follows the alkane formula, which is CnH2n plus 2, which comes directly from table Q. So for alkanes, for every number of carbons, you have 2 times that plus 2 the number of H's. If you could also draw this if you wanted to, but that takes more time. This is the easiest way. So alkane, again, you want anything that ends in A-N-E, and that is answer choice A, butane. Again, we know it's not butene because we know we have single bonds. And we know it's not decane. This also ends in A-N-E because dec means 10 carbons, where butane, but, means 4 carbons. So it's a mix between table P and table Q. Number 3 says what is the IUPAC name for the organic compound that has this formula. So this is our branch. One of the first things you wanted to do is find the longest chain. So if I highlight this in blue, that's a 5-carbon chain. Okay. Let's check out the other options. In purple, we have that 3-carbon chain, which is an option. And then in green, we have that 5-carbon chain. So our longest chain has to be 5 carbons. Okay. So let me just get rid of all of that. Let's just go with this 5-carbon chain. It will not matter, but I like this one. Okay. So a 5-carbon chain means pent. 5 carbons is pent. That's what table P tells you. Now there are single bonds between these carbons, so that means ane. So as of right now, we've named everything in this blue box. Now the only thing we haven't mentioned is this group in the red box. So 1 carbon, we know that is meth, and when it's a branch, you end with YL as an ending. Okay. And then we have to give the address that this, methyl group lives. So right now our name has methylpentane, and we got to give it a home. So there are two ways of looking about this. If we label our carbons 1, 2, 3, 4, 5, it looks like it's labeled on the fourth carbon. But remember yesterday we talked about how we have to name it on the smallest carbon. So if you label this 1, 2, 3, 4, 5, we could say it's on the second carbon or the fourth carbon. So if they don't match, you have to use the smallest number. And what's smaller, 2 or 4? Hopefully you all say 2. So that means it is 2-methylpentane. So again, pent means you have the 5 carbons in the longest chain. ANE means you have single bonds between those carbons. Methyl is the group that's hanging off somewhere. And then that 2 tells you that methyl group is hanging off of carbon number 2. So our answer is B. Okay. Number 4. This says we want an unsaturated hydrocarbon. So remember, unsaturated, you need a double bond or a triple bond. So a double line or a 3 lines. So right off the bat, we can get rid of A and C. Now B and D both have double bonds, but it says hydrocarbon. Now remember, a hydrocarbon has C, hydrogen, and carbon only. Okay? Choice D has chlorine. Chlorine is not H or C, so it can't be D, meaning the answer has to be B. Next question, number 5. The name of this compound. So again, our first job is to name the longest carbon chain, and that is 5 carbons long. So we get pent. That doesn't narrow down our answers at all. Next thing is this double bond, and you end a double bond with ENE. So now we can get rid of D and B. But now we got to give a home to this double bond. And if we label our carbons 4, 3, 4, 5, it could be on number 4. Or if we label it the other way, 1, 2, 3, 4, 5, it could be on number 2. Remember, you always want to tell the person who's looking at the name of the compound where the double bond starts. So does it start on carbon 2, or does it start on, carbon 3? And again, you want to pick the smallest number. 2 is smaller. So we have 2-pentene, which is choice A. Again, pent, you have 5 carbons. Ene means there is a double bond somewhere. And this 2 tells you that the double bond starts on the second carbon. Okay. Number 6, an unsaturated hydrocarbon. Remember, unsaturated, again, you want a double bond or a triple bond. And together, those are multiple bonds. So we don't want single bond, we don't want single bond. So that means A and C are garbage. And then when we're stuck between B and D, you only need at least one double bond or one triple bond. Instead of saying double or triple, they just use multiple bonds, which is the same thing. So that is B. Number 7 says, what is 2-butene? So if we break this apart, but, again, this is not but, means you have 4 carbons. Okay. All of these have 4 carbons, so that part of the name does not help. If we look at ene, this means you have a double bond somewhere. So we can get rid of A, because A does not have a double bond. B, C, and D do. And then, get a different color. This 2 is the location of that double bond. So that means this double bond has to start on carbon number 2. It does not mean you have 2 bonds, so it cannot be B. If you wanted to say you had 2 double bonds, which you might, I doubt you'll see it, it would be 1,3 dibutene. This di would mean you have 2 double bonds, and these would be the locations of them. Okay, so we know the double bond has to start on carbon number 2. So here, in choice C, the double bond starts on carbon 1. So that's not right. This would be 1 butene. And for choice D, you have the double bond starting on carbon 2, which is D. So that is perfect. And this one, it doesn't matter which way you label them. It both starts on 2. If you read left to right, it starts on 2. If you read right to left, it starts on 2. Number 8, a double carbon bond. So again, a double bond is in the alkene family. So you want anything with an ENE ending, and that is B. So A is a single bond. B is a double bond, that's what we're looking for. C is a triple bond, the alkynes. OL is something we'll learn later on this week, and that's the ending for something that has the alcohol functional group. Again, topics for it later on this week and next week. Number 9 says which is an alkyne. So this is a table Q question. So as soon as you go to table Q, look for the word alkyne, and it wants the formula. And the formula for an alkyne is, my bad, question 9, this answer choice says CnH2n minus 2. So the answer choice is D. So just to recap, CnH2n plus 2, that is an alkane with single bonds. CnH2n, that is an alkene, which is double bonds. And CnH2n minus 2 is an alkyne, a triple bond. Okay. Oops. Okay, number 10 says the homologous series, so that's Q for table Q, of the hydrocarbons that include the compound 1-heptine. So what I want you guys to focus on is the YNE ending. So YNE equals a triple bond. And then you want to figure out what formula that matches up with on table Q, and that is answer choice B. Okay. Number 11 says the total number of electrons shared. So this is a question that you have definitely seen before. So we're looking within that section. And it's important that you know that we're looking for a total number of electrons and not pairs. So a triple bond means you have 3 pairs of electrons, which is the same as 6 electrons total. And so the answer is A, 6 electrons. Be careful, they can have the same question, but ask for pairs or ask for total electrons. Just make sure you're reading these questions carefully. Number 12 says 2-pentyne. So pent, if we look at this, means you have 5 carbons in the longest chain. So this longest chain is 4 carbons, can't be A. This longest chain is 3 carbons, can't be B. So now we have C and D. They each have 5 carbons in their longest chain. Then YNE means you have to have a triple bond somewhere. And the only one with a triple bond is choice D. This 2 gives you the location of the triple bond, and it does start on carbon number 2. Okay. Number 13, the paragraph, it's kind of small. It gives you a whole bunch of cool info about Florida and oranges. Cool. Does not matter. What does matter is, in terms of bonding, why the hydrocarbon ethene, so they told you it was that, is classified as unsaturated. So there's a few ways you can look at this. Ethene, falls into, even by the name, it is an alkene, which means there are double bonds present. So we can say it's unsaturated, I'm going to abbreviate, because there are double bonds. That's simple enough. That's all you had to have said. And again, you know that because of the ending E-N-E. And you can also see, if you wanted to, that formula does fit into the alkene family in that formula. The CnH2n. Number 14. Again, the same paragraph on Florida oranges. But now it's asking you for the empirical formula of ethene. So again, ethene is this C2H4 compound. An empirical formula from way back when is the simplest ratio. So how can we simplify C2H4? Divide everything by 2. So you get 1 C and 2 H's. So between here and here we have the same ratio, but now we have the simplest form, and that is the empirical formula. Number 15 talks about gas and coal. So let's see. It says draw the structural formula, blah, 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 but no one really cares about this. Actually, I need some of that. It says, so we don't need the sentence. Draw the structural formula for the hydrocarbon that is 2% of natural gas. So 2% of natural gas is butane. Everything else is garbage. So it says draw butane. So but, that BUT, means you have 4 carbons. Ane means you have single bonds between all of those carbons. And then that means everything else has to be an H. Just like that. And that's it. Lastly, again, same paragraph on gases and stuff. It says, again, nobody really cares about this section. Write the general formula for the homologous series that all these gases are a part of. So we have methane, ethane, propane, butane. They all end in A and E. So they're all alkanes. And the formula on table Q, so you got to look at table Q, is CnH2n plus 2. And that's it. And this is question 16. And that is it. So a lot of this naming stuff, it seems complicated, but if you break it down, it's not that bad. And almost basically everything is on the reference table. So that is it for today. Have a wonderful day.